Okay, so we want to continue on with our little exercises related to our trig functions here. And we've got your trig table, and this is on page 14. Emily, can I get you to shut that door for me, please? Dang. No, it slams. And so what I want you to do in this part, give the following value for sine. So these are the values for sine. Use the trig table to determine the angles between which the actual angle must be. Then use your calculator to determine the exact value and round to the nearest hundredth. And let's just do one to get you going here. So, of course, Marshall needs to put on his glasses to see this. So I said I've got a value of 6.09 or 0.6092, and I look at my sine column up here at the top, and I scroll down with my eyes to find a value that's the closest to 0.6092. And what two values on this table bracket 0.6092? What two values bracket 0.6092?
37 and 38.
What's that?
37 and 38.
Okay, so 37 and 38, the angle of 37 degrees and 38 degrees. So what I would want you to put here, angle is between 37 and 38 degrees. Then I want you to calculate the exact angle. And we remember that to find the angle, we use the inverse sign, right? We use the inverse function to find the angle. Okay, so I want you to do this for these values for sine. And think, this means that the length of the opposite side is 0.6092 times the length of the hypotenuse. And I kind of want you to think about this. If you knew that the opposite side was about 6/10 of the length of the hypotenuse, if it was about 6/10 of the length of the hypotenuse, what would that mean for the angle? And if you practice that enough, you'll actually get to a point where you can kind of predict if the sine is such and such, my angle is going to be about such and such. And we also remember that a value of 0.5 for sine is where the angle is at 30 degrees. So if the sine is 1/2, the opposite side is 1/2 as long as the hypotenuse. That's a value of 30 degrees. And that's a useful thing for you to do. The other two of these, I want you to do the same thing for cosine. Given the following value for cosine, use the trig table. Okay? And I've used the same values here. And the reason that I've used the same values is because I want you to recognize that these are reciprocal functions. Sine and cosine are sort of the opposite of each other. And you'll find out that the angles will be complements to what you get for the sine. And remember that if the angle is going to be greater than 45 degrees, you have to go down to the bottom row of things to look for that. So if I am at a cosine of 0.6092, oh wait, that's exactly the same angle. So cosine of sorry about that. Cosine of 0.6092. So that's exactly the same angle, isn't it? Okay, so sine on one way and cosine on the other, except it's not the exact same angle because now I have to go across to the other side, right? So here it says 37 and 38 degrees. That's where the cosine would be 0.6092, but I don't look at the angles on the left side. For that, I would have to look at the angles on the right side, right? So it would be between 52 and 53, and that would be the complement to 37 and 38, right? What's the complement? They add together to get what? That's a supplement. So the complement they add together to get 90 degrees, right?
Yeah.
Okay. So, and then we'll look at those in just a, so go ahead and work on those two things. Some of you might be done already. I don't know. Are you guys done already?
Maybe.
No?
I have one more point left.
Okay.
Oh, yeah, two more.
So I'm going to give you 10 minutes to finish. Not everyone's going to be able to do this as quickly as everyone else. So I'll give you 10 minutes. Or until everyone's done. And I can come, you can use your neighbors for help, or I can come around and help if you need help. Is this making any sense? Okay. So for this value here, I want to look and find out what the value of sine is. I've asked you to look, so find the value. Sine's right here, and this value 0.0035. What two numbers is it between? And it's actually between 0 and 0.0175. Do you agree? Okay, so that number is between these two numbers. So the degrees are going to be between 0 and 1. Okay. And then if I look at 0.1987, so 0.19, there's 0.19, and it's 0.1908, so it's going to be between those two numbers. And you look at line degrees in between that. Okay. And then 0.88, I scroll down all the way down here, and I don't get to 0.8. So I look at where sine is on the bottom row, and I go back up. So 0.88. So it's going to be between, so if I'm using the sine on the bottom row, I have to go across. So it's going to be between 62.
So that's just the, look at biggest thing about.
You have a calculator.
Makes it even use degrees. Oh, yeah. Oh, yeah.
And then those two the last one here, so I'm going to
Thank you. Yeah.
Okay, and then, so I want to use this number now to find the exact angle and to make sure that I actually did this right. And so when I look at the sine, it's the length of this divided by the length of this. And this is always going to be smaller than this. So this divided by this is always going to be less than 1. And the longer this is, the greater that angle is going to be. The shorter this is, the less that angle is going to be. So I can say that this value right here, the value of sine, is the value of the opposite side over the hypotenuse. So that's what this number is, 0.6092. I took this and I divided it by this, and you can see that that's less than what it should be. But what if I want to, and so the sine of this angle is somewhere between 37 and 38 degrees. So what if I want to actually find out what the angle is? This way I'm finding out what the sine is, but I want to reverse the process. I want to find out what the angle is. So we do something called the inverse. So we take sine to the negative 1. What you're going to do is you're going to get second sine, second sine. And that'll give you that sine of the negative 1. And then you put second sine. And just like we predicted, so I want you to do the same thing with these four numbers. And then you'll do the same thing for cosine. So cosine is going to be in this column, or if it's above 0.7, it's going to be in this column. And again, if you're using the bottom one here, you have to work the angle. Okay? Give it a try. Okay, so what
Okay, that is not
ends up happening for 0.6092 is that now we're using the cosine right here. And because the cosine is greater than less than this, right, we come down here, and we didn't get 0.692 yet, so we're going to have to go back that first way. Yeah, we did get to the same angle here, but in this case, since we're using this, we're going to go with this. Okay, do you want that calculated the inverse sine? Yeah, because that's what you're going to need to do, right? So the sine is the opposite of the hypotenuse, right? The sine of the angle is so I have the opposite side.
Oh, we're on the right top.
No, divide that by
I just want to work.
this side by this side.
They're breathable. You can
This is always going to be less than this side is always shorter than this side. And so, so what if I want to reverse that process? I found out that this side divided by this side was. What if I want to know what the angle is that gives me that?
For some reason.
Okay, and that's the inverse, as the opposite. So that's sine of the negative 1. So what I do is get second sine. So second sine, hit second 1, 2.
I'm so fed.
I mean, I don't.
And see that it gives you that angle there. And then plug that value back.
No, you're I refuse to.
Yeah.
I've never done that before.
They're heavily, they're too popular for me. Inuyasha.
Did you start it for it?
What?
Did you start it for it?
No.
Dude, I haven't seen those. That one seems actually interesting.
Inuyasha?
Yeah.
I've just seen the movie.
Dude, it ran for like 10 years though.
Okay.
Over 10 years.
Yeah, I got all the anime. Anime lore. Pokemon lore.
Dude, Pokemon's in
Oh, so you actually went through the other side. Okay, so,
There's no max.
Yeah.
You don't even know who Ash was.
so what's this number, 0.1987? So I stole that and 1.19, and then, so 0.1987 is between this number and this number. And then my values would be less.
Saying.
Now, I
have a backstory.
don't see that number scrolling down here, if it's less than 300. Then I'm gonna have to look at the size of okay, we'll see this, and then go back up. So in between these two numbers, but if I'm using this, I have to go over to the other side and use those things.
Yeah.
So okay, so make it so that it's a scientific calculator. Oh, yeah, you do. Yeah. So go to your calculator. Turn it on its side. It should. Okay, so there's. Okay, so the way this works. Okay, the opposite side of the hypotenuse. Okay. And the sine is this length divided by this length, right? It's the opposite of the hypotenuse. The sine of the angle equals that. And you can see that this side is never going to be longer than this side. So whatever this value is, it's always going to be less than 1. Okay? And that's why I always think it's less than 1. But what if I wanted to go the opposite way? I can find out that this side over this side equals 0.692, right? But what if I want to know what angle is responsible for that particular side? And the greater this number is, right, the greater that angle is going to be. Okay, so what if I want to know what's responsible for that? So I have to reverse the process to find the sine. That's called the inverse sine. So I'm going to get sine of -1. And then your calculator, so you can go away. So that'll give you the sine, but you're going to get second first. And then that'll give you sine of -1. Okay, so hit it again. So it's off. Okay, and then put in 0.6 over into. Okay, so you hit second and you hit second time. Just hit a point, so hit second again. Third. Second, this sine of the -1, then 0.6. Okay, so this is going to work a little bit differently. Put in 0.6 over 92 first. And then hit second. 37.5. And that's exactly what you predicted.
Yeah.
Thank you. Beautiful. Oh, see, you're done. Oh, you've gone on. Okay, so, let's picture the so if I have a triangle and I've got this angle, so if I divide the length of this by the length of this, I can see that this is always going to be shorter than that no matter what you do. So it's always going to be less than 1. And that's where these numbers come from. For this particular angle, I divided this side by this side, and I got this side. But that's the ratio. I don't want the ratio. I want the angle that caused that ratio. So depending on the angle, I'm going to get a different number for that, right? And I want to know what the angle is, so I have to reverse the process. So to get this value, we have opposite hypotenuse. But to get theta, I want to take the inverse of that side Yeah, so,
So you do second and.
yeah, but you type the number in first.
I couldn't figure out how to get this function on. I couldn't remember how to put this on. I wanted to reach out, but we'll start to decide. Just see what happens. I don't want your meters.
Okay, well, I didn't want you to go that far.
Just one mine.
So, I just wanted you to do the sine and cosine.
Okay.
I was gonna explain the other part. So, okay, so I think we're all far enough along that we can move on. If you're struggling with this, come and see me because you need to be able to do this. So we did the sine and the cosine. And then on page 15, we've got this right here. And I guess I should be using mine. So what did you get for the angle for the sine of, or the inverse sine of 0.6092? What did you get for the angle, the actual angle?
37.53.
So 37.53. And what did you get for the angle of the cosine, the inverse cosine of that?
52.47.
52.47. And if you add those two together, you end up with 90 degrees. And if you did the same for all of those, okay, if you did the same for all of those, you end up with 90 degrees. Okay, so I want you to do the same thing for all of those. And before you do that, let's just read through this. Sine and cosine are said to be reciprocal functions. This means that the sine of one angle equals the cosine of the complement of that angle. And remember that two complementary angles add up to 90 degrees. So if I've got one thing that equals an angle and I've got the other thing that is the complement of that angle, those things should always add up to 90 degrees. And that's why all of these things are going to add up to 90 degrees. So the next thing I'll need you to do is show me that. Go back and find out what those angles are and put those in there and prove that that's the case. And then go ahead and do the same thing for the tangent that you did for the sine and the cosine. Given the following values for tangent, use the trig table to determine the angles between which the actual angle must be, and then find the exact value if you haven't done this already. And again, I want you to think about what these things mean. For the tangent, this means that the length of the opposite side is 0.88 times the length of the adjacent side. So that's probably not quite as. So it would need to be less than 45 degrees because this side would be just a little bit less than this side for that 0.8888 one, okay? So the opposite side is going to be 0.8888 times the length of this side, and that means it'll be a little bit less than this side. So it would mean that the angle would have to be a little less than 45 degrees, okay? And again, if you really work through those, that will help your understanding. So go ahead and do those last two exercises, and I'll give you another 5 minutes or 6 minutes to work on those. If you haven't already done, I'm sure some of you have already accomplished that. Kirsten's already accomplished that.
Maybe.
Yeah. What? Okay, so you got this, well, you just calculated it, right? You calculated that angle. Oh, so that's the one you got for cosine. So, or that's the one that you will get for cosine. So what I'm asking you to do is for the angle that you got for this, 37.53, plus the angle that you got for this, which you haven't done yet. You do that exactly the same way you do this, except you use cosine. Oh, yeah, well, I just showed you how to do that. You said you understood. Okay, so what's this value here? 0.0035. So type in 0.0035. And then hit second the degree sign. And then you would second and then same. Okay, so that's the angle. What would be 0.00? Okay, but you don't find this one. You find that down here. So do the same thing for the cosine. So type in 0.00.602. Then reverse cosine. Okay, now did you somehow get into radians? Okay, so you might be in radians. So it says it in degrees. Okay. Okay. So do it in the 2.692. And then second, I'll say already there, some cosine. So 52.4. So that's where you got that.
He's like so weird.
Okay, and so what I wanted you to do is add that and that.
Just
So, finish those off. Finished up?
Yeah, so like basically one big term, but things or the two. Just start drums.
Well, like that.
It's just one
No, over some experimental thing. British guy, British man with projects.
exactly that kind of time.
British people scared me. How big they're looking. Figured this
Oh.
You guys figured it out.
Yeah.
No, it goes to the Thames. If they do, it's like this, the guys really keep it backwards, like. No, it's good. They like right side of each arm using each now. What do they do? I can't, did you see it? In today's $5 and don't officially for like 5 years. You know, that's a hope there, like the deep, or it's just really wow.
Thought Chase would show up.
Maybe if the group is swim.
Okay, so the problem there was that you were still in radians. So go back and recalculate that one.
Yes.
So try it again.
Imagine I'm sitting there, 2 degrees. Imagine.
You can usually figure out right away when you were.
Yeah, because you just start getting obnoxious things, but that's not right.
Best movie ever.
I know, it's so good.
That movie's so
So not.
I had to watch it one time and I wanted to die.
You have to understand that it's mocking fairy tales.
Yeah, I don't get it.
Because otherwise, if you don't understand that, it's
Okay.
kind of rough. But the whole thing is just mocking the fairy tale story. It makes more sense once you've read the book.
In a way, it's
Okay.
good in that it's purposely bad.
Yeah, exactly.
Best movies,
Except for the bad things,
Yeah.
Yeah, no. But I want you
No,
yeah. Well, I wanted to
just at least write it down.
So,
Everything that you do in this class, you have to show work. So you can't just tell me 90, I'll only give you one out of 3 points.
Yep, you're watching. You have to.
That's exciting that. Anime is the worst thing that
Have you read the book?
No. Is it better than the movie?
No, it's not actually.
It's very, very close to the movie because it's the author directed it.
Okay.
But in here, you can see like the author has like side notes and stuff, and it's literally based on it.
So there's more intent.
Yeah. It's just
Well, that
making
just crushes me because I wanted to,
You wanted to what?
I want it to be a real fairy tale. I don't want it to be a mockery of a fairy tale.
The movie is kind of like a real fairy tale. The book mocks all of it, and I love it.
Inconceivable.
Anybody want a peanut? It's so good. I feel like The Princess Bride, you either love it or you hate it.
Yeah, I do.
That's kind of.
If you are still working, that's okay. Go ahead and I'm going to assume that you're getting this to the point that will work. But if you are struggling with this, come and see me. We need to know how to use this in physics now. And this is the kind of thing that you've done in math classes. You've worked on this and you've tried to figure out how to use sine and cosine in math classes. But my guess is that you probably didn't use it in real life physics kinds of situations. And it makes a lot more sense if you know how to use it to actually accomplish something. Okay? So, as an example of that, I am a person that's kind of strange. I walk around, when I'm walking around out in the world, I'm doing physics problems in my head. Okay, I just am. I don't know why. And I was walking my dog the other night. Okay, I was in the park and it was near sunset, and I noticed that my dog that's a terrible dog. It's more like a parrot. Yeah. Anyway, I noticed that my dog's height was a certain height, and I noticed that the shadow that the sun cast was a certain length. Okay? I was paying attention. I noticed that the dog was a certain height, and I noticed that the shadow that he cast was a certain length. And I wanted to know what the angle of the sun was. Okay? So I was able to figure out what the angle of the sun was because I knew how to do this. Okay? And that's just an example. You probably don't walk around doing physics problems in your head, but there are real world applications to this kind of thing. And who knows, maybe someday, even if you're not in physics, you may use something like this. Anyway, in the introductory problem, we saw that in solving some types of physics problems, we have a critical need to determine the value of unknown lengths of sides and angles of a right triangle. Remember that our problem was our problem was that we were trying to figure out how the wind, and I'm sorry I keep scratching my nose, it really itches. It's not picking it. The problem we had was we wanted to know how the wind was affecting the direction and the speed of the airplane. So we needed this a skill. Underlying the skill is the understanding that in a specific angle, so I'm talking about this particular angle, whatever that happens to be, or this particular angle, whatever that happens to be, or this particular angle, whatever that happens to be, at a specific angle, the ratio of the lengths of the sides to one of the other sides is a constant value. Doesn't matter what the lengths actually are for a particular angle, the ratio of the length of one side to the other side is a constant value. And so we can look these up, and you've done that on a trig table now, and you can find them using a calculator. You know how to do both of those things now. Knowing these ratios for a particular angle, if you know the length of one of the sides, you can figure out the length of the other sides, or if you know the length of two sides, you can determine the angle associated with those two sides. So following practice will guide you through and give you practice in the strategy we need to follow to develop these necessary skills. Okay, what time is it? Does that say 38?
It's 8:38.
Okay, good. Okay, so given the right triangle illustrated to the right, given the, and what do I mean when I say given? It's just the value that you're given, right? I'm giving you that value. Given this right triangle, given this angle. Make sure we know how to label the sides, right? Which side is the hypotenuse? The dotted one, right? Okay, and with reference to this, which is the adjacent side? Okay, and then this is the opposite side, right? So I'm looking to the opposite side. This is the side next to the angle, okay? And we've already defined the sine of theta as the ratio of the length of the opposites.
That we're supposed to have.
Yes.
I don't think it passed.
That would be helpful.
Yeah, just a little bit.
Perhaps.
And you waited that long to...
Yeah, I was looking to see if it was in here. To see if I was missing where it was at.
Yes.
I'll be honest. Don't get mad at me for waiting that long though, because I didn't hear anyone else saying anything, so.
Okay, class, you waited that long to tell me?
Thank you.
I don't know what's going on.
Just because you didn't want to do the stuff, right?
We didn't understand.
What's the name ready?
Okay. So, obviously you're going to label these and you're going to fill in. Sine is opposite to the hypotenuse. And I'm just reviewing real quickly what we already know. Cosine is the adjacent compared to the hypotenuse. And then the tangent is the opposite compared to the adjacent. And then just so we can never forget it, we have this wonderful mnemonic called SOHCAHTOA. Okay, just so we can't forget this, sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Okay, and so opposite.
A or no?
US?
Okay, so Toa. Okay, we're all good with these basic facts, right? We're all good with this. It took me a very, very long time to learn this because I learned it in a context where it wasn't really applied to anything, and so it just didn't make sense to me. But we're going to make this make sense. Okay? And remember that we commonly use abbreviations listed in question 1 for the hypotenuse, adjacent, and opposite sides. So using those abbreviations, we recognize that we can write mathematically that the sine is the opposite over the hypotenuse and the adjacent over the hypotenuse and the opposite over the adjacent. And the reason that I'm beating this to death is because the strategy that you're going to use to solve problems requires you to have a really intuitive sense about this. You're going to use these formulas in your solutions, and we created an, what was I supposed to write for number 4? Oh, okay, I see, never mind. So that's where SOHCAHTOA should have gone, right? Sorry about that. Okay. Now, let's see. For the following right triangles, you've been given all 3 sides of a triangle. For example, for triangle 1, you've been given that one side has a value of 14.7, another has a value of 3.31, and the last has a value of 14.3. Now, get used to the idea that we will commonly label sides of a triangle with variables that mean something to us, okay? Remember that for our airplane, we had an arrow that went this way, and we said that it was 100 meters per second. The airplane was traveling at 100 meters per second. We're going to label that because we want to label that with something that means something to us. We're going to say that that's the velocity A, okay? That's the velocity A. And then remember that the wind was in this direction. And we're going to call that velocity B, and we're going to say that's 20 meters per second. So that's what I mean when I say that we're going to label these things with labels that mean something to us. And then we said that if I connected those two, the beginning and the ending point here, the length of this is the actual velocity of the airplane. The airplane thinks it's going 100 meters per second. The wind thinks it's going 20 meters per second, but if I'm standing on the ground watching the airplane, I see it going 102 meters per second. Okay? I want to be able to find out what the plane is actually going, not what it thinks it's going, and not what the wind thinks it's going. And obviously, I understand that the airplane doesn't really think, and the wind doesn't really think. Okay? But it helps visualize what we're talking about. So anyway, in the first triangle, V, VA, and VB are referring to velocity, velocity A, and velocity B. It will not only be important for you to recognize the hypotenuse, the adjacent, and the opposite side, but that these values correspond to V, VA, and VB. Okay? And you can substitute these values in for opposite and hypotenuse and adjacent to help you solve problems. Okay, so here's what I want us to do. And I'm only going to ask us to do one of these, and then I will ask you to do the others outside of class. Okay, so because I want to get to an additional point here. Okay, so this is really, really, really basic, almost busy work. It's not totally busy work, but I do want you to do these just so you really cement these into your brain. So here's my triangle, and I've said that this velocity is 3.31 meters per second. This velocity is 14.3 meters per second, and it kind of looks like our airplane problem, doesn't it? It doesn't have to be, but it kind of looks like it. And these are parts of a right triangle, and with reference to theta 1, this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse, right? And so the point here is we need to be able to substitute our labels in for adjacent, opposite, and hypotenuse, because that's going to help us solve problems. So what I've done here for theta 1, that angle, the sine is the opposite over the hypotenuse, but oh, wait a minute, the opposite is VA, so I can substitute that in for the opposite, and oh, wait a minute, the hypotenuse is V, so I can substitute that in, and then I can substitute my numbers in for those, and then find out what the sine is. Okay, now, as with all of our physics problems, you have to show your work. You can't just write out an answer, because a lot of you can just look at the triangle and say, oh, the sine is 0.225. You would just put the numbers in the calculator and find that out. I need you to show me that you know how to get that. Just telling me what the answer is doesn't tell me that. So for the cosine, I would say, oh, I know that the cosine is the adjacent over the hypotenuse. And oh, by the way, the adjacent side for this angle is, oops, let's go back. The adjacent side is VB, and the hypotenuse is V. Oh, and the adjacent side is 14.3. And you don't need to put units in for these. We're just looking at the ratios. 14.7, and I don't know what that turns out to be. But I want you to do this for triangle 1 and triangle 2 and triangle 3. I know that's a lot of stuff, but you have to be able to substitute labels in for the correct side of the right triangle. That's critical to our strategy. And if it's something that you can already do, that's fine. Just quickly get the other thing done and out of the way, and be done with it. But if it's something that you need practice on, that will help. Now, what I want to actually really get to here before we quit is how are we going to use this to find real values in our problems? So we're going to start by saying, let's use our knowledge to find missing pieces of information. If we are given an angle and one side of a right triangle, we can always find the lengths of the other two sides. And I'm going to give you a strategy, right? You know that I'm really big on strategies because I don't want you to get into a situation where you think something is so complicated that you can't start the problem. If you have the strategy, you just follow the strategy and the problem will lead you through the problem. Okay, so here's my strategy. It's always a good idea to label a right triangle with hypotenuse, opposite, and adjacent. Okay? Then you're going to ask the question, what side have I been given? Have I been given, have I been given the hypotenuse, the adjacent side, or the opposite side? What side of the triangle have I been given? Then ask the question, what side do I want to find? Okay, so if you're given the hypotenuse and you want to find the adjacent side, adjacent and hypotenuse, you automatically know you need to use the cosine to solve the problem. Okay, if you're given the adjacent side and you want the opposite side, you automatically know you need to use the tangent to solve the problem. If you're given the opposite side and you want the hypotenuse, you automatically know you need the sine to solve the problem. So I said my next step is, because I can remember which trig functions are related to which sides, because I know SOHCAHTOA, which trig function that contains both the side that I've been given and the side that I want is the correct one. Okay, and I just showed you how to do that. So label, then say, what do I have? What do I want? What trig function will solve the problem for me? Okay, and here's the key thing. You don't have to think about this. Once you know the trig function, you just write down its formula. If you know that you need the sine, you say sine of theta equals opposite over hypotenuse. Then you substitute the labels in, VB over V. Then, if you want VB, isolate VB. Get it by itself. If I want VB, I need to multiply both sides of my equation times V, and that will isolate VB for me. V sine of theta will be VB. That gives me my answer. All I need to do then is plug in the values and solve. Okay? So let's walk through this strategy. Okay? And by the way, I'm not asking you to write down these questions. Okay? These are questions that you'll ask in your brain as you develop the ability to use this skill. But in each successive problem, I've decreased the amount of guidance that I've given you here. So this first one, I've gone through this process the whole way. So here's my triangle, and I've said given side V, there's V right there, and already your brain should be going hypotenuse, right? I've been given side V, and I want to know, related to angle theta 2, what the value of side VB is. Okay? So, I'm going to write this triangle out over here again. And that's VA, and that's VB, just so I can walk through the questions. V equals 23.9. Okay, and that's a velocity, so I've got meters per second. So I'm going to label my triangle. That's the first thing I'm going to do. I'm going to say, with reference to theta 2, that's right, what I wanted, right? Theta 2. Okay, with reference to theta 2, this is the hypotenuse, this is the opposite side, and this is the adjacent side. Okay? What have I been given? I've been given V, right? V is the hypotenuse. So I have been given the hypotenuse. Related to angle theta 2, what side do I want? I want VB, so I want the opposite side. Therefore, since I have the opposite and the hypotenuse, the SOHCAHTOA thing that matches that is SO, sine opposite hypotenuse. So I'm going to write down that formula. I'm going to say sine of theta equals opposite over hypotenuse. But oh, by the way, it's also the same thing as VB over V, right? I haven't labeled opposite hypotenuse and adjacent to start with, but I have given them other labels, and I'm just substituting the correct labels in for the opposite and the hypotenuse. And then I've said, oh, what do I want to find? I want to find VB. Normally, I'll put a little circle around that so I know that that's what I want to find. I want to get VB by itself. I know that sine of theta equals VB over V. Therefore, in order to find VB, I need to multiply V times the sine of theta. And you can even draw these little arrows around if you want to. You don't need to. But if that helps you see what you need to do to solve the problem. And now all I have to do is plug my numbers in. VB equals, V was 23.9. And the angle was 71 degrees, so I need the sine of 71 degrees. Okay? And if you use this strategy, you didn't have to know how to solve the problem. You just follow the steps of the strategy. You guys can close those blinds if you want. That sun looks pretty bright. Okay? So, and here I actually did that multiplication, right? I multiplied both sides of the equation by V and showed that it canceled out. You don't have to do that. I like to put my isolated variable on the left, but then I just plug the values in and I solved that. Okay? So, I've given you less guidance on this one. I've said given side DA, I've been given this side that's 414 meters, and theta 1 equals 32 degrees. I want to find dB. So my questions are, well, first of all, I'm going to label, right? I'm going to say this is the hypotenuse and related to theta 1. This is the adjacent side, and this is the opposite side. It works so much better if you do the labeling. That way you can see it. Then I'm going to ask the question, what do I have? What have I been given? I've been given the hypotenuse. What side do I want? I want the adjacent side. Is that what I wanted? Yeah. I want the adjacent side. Oh, by the way, the function that does that is cosine. So I write down the definition of cosine of theta. Cosine of theta equals A over H. Oh, by the way, the adjacent side is also dB. And by the way, the hypotenuse in this case is dA. And I want to find dB. I'm going to put a little circle there, and I know that in order to find this, I'm going to have to multiply dA times the cosine of theta. So dB equals dA times the cosine of theta. I've isolated it that way, and I just plug my numbers in. dA is 414, and cosine of, we said 32 degrees, and I just solved my problem. So, as far as these blanks go, what side have you been given? You've been given the hypotenuse. What side do you want? You want the adjacent side. The trig function that contains those is the cosine. The formula for that trig function is cosine of theta equals A over H. Substitute labels from the diagram into this formula. Cosine of theta equals A over H equals dB over dA. And then isolate the value. We isolated it. We said dB equals dA times the cosine of theta. And then we plugged in the values and solved. What did we get for that? 414 times the cosine of 32.
96.68.
96.7 meters per second. And then you want to go back and sort of check if I got something that makes sense. Okay? If I know that this is 414, okay, and I got 90, what did you say, 96.7?
Yeah.
That doesn't make any sense, does it? Okay, according to my triangle, this line should be a lot longer than 96.7. Okay, it's almost as long as that 414. So, who got a different cut?
I put 114.
351.09.
351.1. And I asked Kirsten to make a mistake on purpose, knowing that it would provide a good illustration for how to check your work. Okay? Use this to figure, hey, that just doesn't make any sense at all, did it? There's no way this is 96.7 meters. So use that to help you check your work as well. Okay? So what I want you to do, and we're not going to quite finish this, what I want you to do is finish the busy work triangles that I talked about. That shouldn't take you more than just a couple of minutes. And then do the triangle 3 and triangle 4 for the section that we're on. And then we'll come and finish that next time we're in class. Okay? So that's your homework for this time. If you're struggling with it, come and see me. Okay? But I want you to have that done by next time. And I want your other packet now. And it's okay if you didn't quite finish the other packet. You'll still get full credit. Is this making any sense at all? Yeah? A little bit? Maybe it's fuzzy? I hope the instruction in this is at least as good as it was when you were going through it in your math classes. If you haven't had this before, then obviously that's true. But it's also worse than what you had in your previous math classes too. Please come and see me if this is not making any sense.
Yeah. Oh, take a photo.